This week on the show, we have a packed episode of shell text processing, data rebalancing on ZFS mirrors, security headers adding with Relay D, ZFS file system hierarchies in ZFS pools, speeding up Z-shell, how Unix pipes work, grow ZFS pools over time, the real reason why ifconfig on Linux is deprecated, clear your terminal in style, and many more things in this week's episode of BSD Now. BSD Now, episode 344, Grains of Salt. Recorded for, April 1st, 2020. This is Benedikt Reuschling speaking, your co-host.
And I'm Alan Jude.
Yeah, we're doing things a little bit different today, or when the time when we're recording this thing, but all the things that we have here in this episode are live and true. Trust us. All of these things are, of course, from the web, and you can never trust the web on April 1st, so yeah, take your pick. The headlines have text processing in the shell for you today.
So this is, the article is part of a self-published book project of Balthasar Rubelero and Etienne Rodu, who are ex-roommates and friends and are trying to empower the up-and-coming generation of developers and looking at some of the interesting Unix tools. So they're talking a bit about text processing in the shell. One of the things that makes the shell an invaluable tool is the amount of available text processing commands and the ability to easily pipe them one into the other to build complex text processing workflows. These commands can make it trivial to perform text and data analysis, to convert data between different formats, to filter specific lines, and so on. When working with text data, the philosophy is to break any complex problem into a set of smaller steps and then solve each of those using the specialized tool. So the examples in the chapter might be a little contrived at first, but this is by design. Each of these tools was designed to solve one small problem. They, however, become extremely powerful when you link them together.
The pipe is your friend.
Yep, so we can look at our first example here is cat. So if you cat a file, it prints out the content of the file. The general purpose of the cat command was cat multiple file names, and we concatenate them all together as if it was one big file. Or the head command, which takes the first 10 lines by default, or 5?
I think it's 5, but could be mistaken.
Some number of lines by default of the file, or with the -n flag, you can specify. In this example, they do head-n2 for metadata.csv, and they get the first and second line, the first one being the names of all the columns, and the second one being an example of the data. If they change the number, they will get that number of lines. And then there's the counterpart, tail. So tail-n1 metadata.csv will give you the last line from the file. They also have other examples. For example, tail-n plus 42 can actually show you the 42nd and 43rd line of the file.
Ah, cool.
So it will start X lines through the file and print the rest and so on.
It's 10 by default.
And you can also do tail-f to continuously tail the file, including, as things are getting written to it, you can continue to see them.
Yeah, also useful.
And then there's, word count for counting how many words are in a file, or with -l, how many lines, or with -c, how many characters, or by default, all 3 of those. And then grep for picking out certain lines from a file and so on. Cut to choose certain columns or fields based on a delimiter. For example, with a CSV file, you can say, break columns on a comma and give me field number 1 or 2 or whatever. Paste command works the other way around, allowing you to combine things back together as if you would, basic cut is paste is the opposite of cut.
There's always examples in this post. It's good to see the differences or the output.
And they walk through awk and tr and fold and sed and lots of other options. And then they start building some real life examples from these, like looking for all of the rows that have the word gauge in them from metadata, and then using awk to separate out where, the 4th column is the word query. Then we print out the 1st and 5th column. And we see that, the MySQL.performance deletes show per second, or whatever the units are, and so on. Yeah, there are a lot of good examples in here. It's a good resource for somebody just starting out.
So for beginners who have never used any combinations of commands or just want to know what these tools do with a quick example, that's a good lookup. All right, then we have rebalancing data on ZFS mirrors. That's one for you.
Yep. So this is on Jim's blog. We have rebalancing data on ZFS mirrors. One of the questions that comes up from time to time, again with ZFS, is how can I migrate my data to a pool on a few of my disks, then add the rest of the disks afterwards? If you just want to get data moved and don't care about balancing, you can just copy the data over, then add the new disks and be done with it. But I won't be distributed evenly across your different VDEVs. But don't fret though, it's actually pretty easy to rebalance a mirror. In the following example, we'll assume you've got 4 disks in a RAID array on an old machine and 2 disks available to copy the data to in the short term. So step 1, we create the new pool and copy your data to it. So he creates a new pool called temp, consisting of a mirror of 2 disks. And we copy the data to it, and he does a scrub here. Then, when he's done, he breaks the mirror and creates a new pool. So he uses zpool detach to take one of the 2 disks out of the pool. So now your pool temp is down to a single disk VDEV, and you've freed up one of its original disks. You've also got a known good copy of all your data on disk 0, and you verified that it's good by doing a scrub before you did the split, or the detach. So now you create a new pool called tank with that one disk from the old mirror by itself, not as part of a mirror, then a mirror of disk 2 and 3, and another mirror of disk 4 and 5. So now you have this slightly wonky pool of an individual disk and then 2 other sets of mirrors. Now you can copy all your data from the temp pool to that new pool that is 2.5 mirrors. Once you've copied all the data, do a scrub again to make sure everything's fine. Then you can destroy the temporary pool because you don't need 2 copies of your data. And then at the very end, you can use zpool attach tank disk 0 to disk 1, and that will upgrade that one single device back into a mirror, and you'll end up with a pool that is 3 sets of mirrors.
Oh, nice.
Yeah, that's a lot nicer than some of the ways I've done things in the past.
Yeah. Well, it's a start. It's a way of doing it. Would you do the double scrubs at the beginning and at the end of the operation?
Well, so you did a scrub before you detach the one disk from your mirror set on the temp pool, so that you make sure that both copies of the mirror are good. Because once you split it, there's no redundancy. So if the data on disk 0 had a checksum error in it, you wouldn't be able to recover.
Right, yeah.
So that's why I did the scrub first. And then, so each time after you copy the data to a pool, you do a scrub to make sure all the disks are right before you do the next step.
So you don't lose any data or there's no changes.
Yes, just so that you can be sure.
Yeah, that's good practice. Okay, so that you know, you can always expand ZFS this way and rebalance data in case you are unbalanced at the moment. Let's jump right into the news roundup for this week. We have an article found about using OpenBSD RelayD to add security headers. So this is an application for RelayD. And OpenBSD's RelayD has the incredible power to add additional headers to an HTTP request or response, is the article's saying. This little how-to takes into account a web server where you would be running both RelayD and HTTPD on the same machine. Bear in mind, we will be using TLS as well, so RelayD will be running on a TLS client and server. Here are some common security headers that you might want to add. The first is the x-XSS protection, the cross-site scripting. The second is x-frame-options. The third is x-content-type-options. Yeah, so these 3. You can reconfigure etc httpdconf so that httpd will listen on the public IP address and https will listen on the localhost port 8080. In the first virtual host definition, I have created a simple HTTP to HTTPS redirection. So this is the configuration file listed here, so you can see which kind of changes you have to make. You then create the etc relayDconf file. The relay D will listen on port 443 and forward the request to localhost 8080, where the HTTPD will then pick it up and serve it to the web secure and encrypted. So you find the relay D config file as well and the changes you have to make there. Then the version of relay D in OpenBSD 6.5 does not yet support SNI, so we have to create some certificate and key links. So you do a couple of ln-s with etcssl server.cert to etcssl 192.0.2.1.cert, which is the IP chosen here, and another soft link created etcssl private-server.key to etcssl private 192.0.2.1 key. Once you've done that, you can start the relay D and HTTPD and try browsing to a website to see that you can reach it and that it's also encrypted and secure. Then go to the site below, which is browserspy.dk, and enter the URL of your website. So you should see the additional security headers added. So this will tell you what kind of web browser security you have, or you're transmitting basically, or you provide with the server. And once that is done, you should get the confirmation that you have actually added those headers on the fly, basically. Very cool. Very nice use for relay D, and it's not too difficult, and the configuration is straightforward, so there's nothing to worry about here. This show is very nicely filled with ZFS goodness. The next one is how we set up our ZFS file system hierarchy in our ZFS pools from our very often featured Chris Seibenman.
Yes, so it says our long-standing practice here has been predating to before the first generation of our ZFS file servers, is that we have two main sorts of file systems. We have home directories, or home dir file systems, and then we have work directories, or work dir file systems. Home dir file systems are called /h/NNN for some 3 letters, and work directories are /w/NNN. The 3 letters is unique across all the different sorts of file systems. Users are encouraged to put as much stuff as possible into work dirs and have as many of them as they want, which matter a lot more in the days when we had Solaris Disk Suite and we had fixed sized file systems. This creates file systems called things like /h/281 and /w/24, etc. When we moved from Disk Suite to ZFS, we made the obvious decision to keep these user-visible file system names and not entirely obvious decision that these file names should work even on file servers themselves. This means using the ZFS mount point property to set the mount point of all ZFS home dirs and work dir file systems, which works and worked fine. However, this raised another question of what the actual file system name inside the ZFS pool should look like, since it's no longer going to be reflected by the mount point. There are a number of plausible answers here. For example, because our NNN numbers are unique, we could have made all file systems simply be pool / the NNN number. However, for various reasons, we decided that the ZFS pool file system should reflect the full name of the file system. So pool /h/281 instead of just pool /281. Because among other things, we felt that it was easier to manage and work with. This created the next problem, which is that if you have a ZFS file system of pool /h/281, pool /h has to exist in some form. I suppose that we could have made these just be subdirectories of the root of the pool, but instead we decided to have them be empty and unmounted file systems that are used only as a container. Kind of like if you do ZFS create-p, which works similar to mkdir/p. It'll create all the parents necessary to create that directory. We create these in every pool as part of our pool setup automation, and then we can make, for example, fs11-demo/01/h/2h1 or 281, which can be mounted everywhere as /h/281. Making these be real ZFS file systems means that we can have properties that are inherited by their children. So you can have, a set of properties that apply to all home directories and a different set for all work directories. This theoretically enables us to apply some ZFS properties only to home directories or work directories and not necessarily the whole pool, and is also useful for things like quotas.
As long as you don't set the read-only option to on for all the home directories, then it should be fine, unless you really want to get on the nerves of your users. Yeah, I like the idea of having it called like /h instead of /home, so it's less typing, although it's not too much, but hey, it's shorter in the output. Okay, so that's the ZFS setup from Chris Seiberman. And then it is time to speed up your Z shell. So this is an article we found, and it's about speeding up ZSH and oh my ZSH. So this on John Lucas' blog goes like the following. I was opening multiple shells for an unrelated project today and noticed how abysmal my shell load speed was. After the initial load, it was relatively fast, but the actual shell startup was noticeably slow. I timed it with time, and these were the results. So you do a loop, you run time, you run Z shell -I-C, and you just exit, and then just count how many times those 10 shells will take to invoke. You can time your own shells with exactly this for loop. And raw bash, as a comparison, was blazing fast. It averaged 0.03 seconds with about 0.02 in userland and 0.01 in kernel. This was an empty.bash RC and other dot files, so it would prove to be a lower bound or goal. So the same in comparison. Then he was averaging 3.14 seconds with 1.64 in userland and 1.5 in kernel land. My Z shell setup was nearly 100 times slower than raw bash. I wanted to investigate what that was going on and why it was so much slower. So the intro to that is, before we begin, it might be helpful to understand how shells in general start up. Shells are just an executable like any other on your machine. Their purpose is to just take user input and behave like an old terminal. And they have predefined control sequences, but in general are fairly extensible. The following is from ZSH man pages. Commands are first read from etc zshell-env, zshell-env. This cannot be overwritten. Commands are then read from $z.dir/.zshell-env. If the shell is a login shell, commands are read from etc/zprofile and then $z.dir/.zprofile. Then, if the shell is interactive, commands are read from /etc/zshellrc and then z.dir/.zshellrc. Finally, if the shell is a login shell, etc/login and $z.dir/.zlogin are read. So there's a bunch of files where configuration file is looked for. When a login shell exits, the files $z.dir/zlogout and then etc/zlogout are read.
When I first saw this, I assumed the problem was actually, so ZSH has a bunch of command completion stuff, and I thought maybe it was, running a bunch of commands to pre-populate something. Mm. But it looks like maybe it's just the ohmyzsh.file, which adds a bunch of that stuff, like completions and corrections and diagnostics and stuff. And it's probably just doing an awful lot.
People just load this stuff and think, I'll be the super hacker type. I need this great shell. But you import a lot of functionality that you probably only use 10% of. Might be a reason. So continuing, this continues a general flow of execution and where zshell starts. My .zshellrc leads to sourcing a few other files, which just behaves as if the contents of those files was passed directly into the shell as standard input. So profiling. We can start by profiling the raw Z shell. It's even faster than raw bash. Okay, so that's good to know. So it must be something in the config. The first step is to figure out exactly what's taking so long. There are a variety of tools to measure performance, but the most useful will be zshell's native debug tools. So this is zshell-xv, which you can also use to debug a shell script. This enables X tracing and verbose output. It's not particularly great for time analysis, though. It does not include timestamps, so we have to eyeball the speed. It's easy to catch a few immediate culprits. For instance, mine hung at least a second on loading NVM. Anything that is few orders of magnitude slower than the other commands will stick out like a sore thumb. The second is an order blind profiler at the top of the zshellrc. Insert zmodload zshell/zprof. This will enable the built-in profiling. And at the end of .zshellrc, insert zprof. The output will give you the worst offenders. Oh, here. This will tell us exactly where zshell is spending most of its time. So in this case, you can see the number of calls and the time it took to make them, and the name of the actual component or the plugin. Fixing the problem. I started by playing around with high-level entry points. For instance, disabling source zshellrc omyzshell.sh from my zshellrc cut my load time down by half, so roughly 1.7 seconds average. I then disabled NVM, and my times plummeted. I had found the main two culprits of slow load times. My new average had become only 40 milliseconds. Well, it's much better. I didn't want to lose the functionality that omyzshell provided, however, so I looked into improving it. I started profiling specific subsections of my zshell like this. So we use a timer variable to get nanoseconds. And then you run, you basically do a now timestamp. Then you run the elapsed stuff by subtracting the now minus the timer. And then you can output the time that it took. I wrapped all the plugin loading and sourcing and profiled each one of those. So you get the times and how much it took. My new zshell start time was about half a second. omyzshell took all the majority of it, but I believe it has to be a valuable addition. I do wish it put a bit more of an emphasis on performance, however. The last thing to do is to lazy load functions and services that I don't need. I found a great sandbox lazy loader here. That's a link to a different this GitHub page. That was useful for nvm/rvm, and any command invocation of nvm from terminal, script or otherwise still succeeds. It just gets lazy loaded the first time it's invoked. Yeah, that's what you want to have. So the observations here is, omyzshell is great and provides a lot of functionality, but it comes at a fairly heavy cost. As you can see above, its overhead accounts for nearly 70% of my load time. There's one other thing to note. omyzshell provides a built-in function vcs_info to provide information about the version control status of the current working directory. However, this is quite slow. For the actual zshell git repo, it takes about 200 milliseconds to parse. In large projects with heavy git history, this will hang your prompt return time for seconds. No one wants that. This won't necessarily impact shell start time, but it will impact the amount of time it takes to actually display the prompt when navigating within a VCS belonging directory. This can be slightly fixed with git config omyzshell.hide-status to 1 on problematic repos, but it would be nice if it did so automatically. Setting the option disable untraced files dirty to true in your zshellrc can help as well, but comes with a lot of functionality or a loss of functionality. Finally, a lot of time is spent in compinit and compdev. These are functions that create or define entries in the local completions cache, and there are a few hacks floating around GitHub, Hacker News, and various forums to try to remedy this, but none are particularly robust or without side effects. So, in conclusion, in the future, they hope to actually recompile zshell with additional profiling techniques and debug information, keeping an internal timer and having a flag output current time for each command in tree fashion. That would make building heat maps really easy. So, I ended with zshell taking about 0.42 seconds or 420 milliseconds to start up. Disabling omyzshell gets the average down further to roughly 50 milliseconds. For now, the extra 380 or so milliseconds are worth it, but I might be tempted to try another framework if I can't get it any faster. This is also a good guide to actually debugging your shell scripts itself, not just the shell startup time.
A lot of it comes down to how often are you starting the shell, and if it's often, then yes, saving 2 seconds there can be a big deal. If it's not often, then maybe it's not something you've worried about in the past.
Yeah, or if it's a login shell on a remote machine and you kind of log in, okay, when do I get my prompt? I want to insert my first command. And then it takes a while to just get you that. There's a bunch of resources as well, so you can see some of the issues and how to speed this up. So definitely check this out. And if you're not using zshell, of course, then this is not too particularly interesting, but you might as well take a look. Next, we ask the questions, how do Unix pipes work?
Yeah, so this is a post by Vergrad Stikavaka. So pipes are cool. We saw how handy they were in a previous blog post, which you can read there. Let's look at a typical way to use pipe operator. We have some output, and we want to look at the first line of the output. So he downloads a long book by Dostoevsky and runs word count-l on it and sees, there are 36,484 lines. If we cat this file, it will print the entire file to the terminal. That takes a noticeable amount of time to finish. Now let's just look at the first 2 lines. So he cats the file and then pipe head-n2, and it prints only the first 2 lines. Now it's done instantaneously. It seems that the cat operation terminates when head is done. Yes, because cat is outputting to the pipe. Once head is done, it closes it, and cat's like, well, the pipe's closed. I can't do anything. I might as well quit. And it says, of course, head-n2 only needs 2 lines of input to output, and that's what it's supposed to output. So how does cat know to stop when head is finished? In this blog post, we're going to learn a bit about how pipes actually work and write a small cat program in Python and Go. So another one, they're looking at it in the other direction. Processes in a pipeline are started simultaneously. So we see like sleep for 100 pipe head. And we see that both sleep and head are started at the same time. From the Unix manual page on pipes, we're learning that if we pipe process 1 into process 2, the second process will wait or block until it receives input. Furthermore, if process 2 is finished, it closes its end of the pipe. This will cause a sig pipe signal to be sent to process 1, which might decide that that means it should exit. So, writing a cat clone in Python. So let's try to write a simple cat clone that mimics this behavior. Instead of reading from files, let's read from standard input. That means we should be able to pipe into the program as well. In Python, standard input is part of sys.stdin. So they import the sys library and do for each line in sys.standardin, print that line. This behaves the same as the regular cat command if we pipe into it. So they cat the text file, pipe into python cat.py, and it prints out all the lines. But does it also stop when we pipe it into head? So we do cat the file, pipe into python cat.py, and then pipe that into head-n2. What we get are the first 2 lines, and then a Python backtrace saying, hey, you're trying to write to a pipe that's closed now, and it throws an error. We see that we get an error, broken pipe error, but if we look closely at the output here, we see that it's printed twice. We can try to catch the error with a try except block, and now we only get the second part of the error output. We see exception trying to write to a broken pipe. So as you know that a terminated process on the right side of the pipe sends a sig pipe when it's done, maybe this means that the signal isn't handled properly. Indeed, a quick search leads us to a section on the Python documentation, namely a note on sig pipe. It gives a recipe for handling it. So they add some of this code here, and it looks like in the event of a broken pipe error, they actually open dev null and replace their standard out file descriptor with dev null. And now it works as expected. Cat file, pipe, Python, pipe head, and it prints just the 2 lines.
Nice.
And then they do the same thing in Go, again, slightly differently, but helps you understand what's actually happening.
Ah, yes. Yeah. Very cool. Yeah. So this is pipes functionality. And this is the second time we feature Chris Seiberman on the show today. The post goes, what do we do to enable us to grow our ZFS pools over time?
So he says, in an earlier entry on why ZFS isn't good at growing and reshaping pools, I mentioned that we go to quite some lengths in our ZFS environment to be able to incrementally expand our pools. Today, I want to put together all of the pieces of that in one place and discuss that at length. Our big constraint is that not only do we need to add space to pools over time, but we have a fairly large number of pools, and which pools will have space added to them is unpredictable. We need a solution to pool expansion that leaves us with as much flexibility as possible for as long as possible. This pretty much requires being able to expand pools in relatively small increments of space. The first thing we do, or rather don't do, is that we don't use RAID Z. RAID Z is potentially attractive on SSDs, where the RAID Z read issues have much less impact. But since you can't expand a RAID Z VDEV, the minimum expansion for a pool using RAID Z is at least 3 or 4 separate disks to make a new RAID Z VDEV. And in practice, you'd normally want to use more than that to reduce the RAID Z overhead. Because a 4-disk RAID Z2 is basically the same as a pair of mirrors with slightly more redundancy, but more awkward management and some overhead. This requires adding relatively large blocks of space at once, which isn't feasible for us. So we have to do ZFS mirrors instead to get more space-efficient RAID Z, or instead of the more space-efficient RAID Z. It says a RAID Z2 VDEV is also potentially more resilient than a bunch of mirror VDEVs because you can lose any arbitrary 2 disks instead of only one from each pair. However, plain mirroring of whole disks would still not work for us because that means growing by relatively large amounts of space at a time and strongly limits how many pools you can put on a single file server. To enable growing pools by smaller increments of space than a whole disk, we partition all of our disks into smaller chunks. Currently, 4 chunks on a 2 terabyte disk, and then do ZFS mirror VDEVs using chunks instead of whole disks. This is not how you'd normally supposed to set up ZFS pools, and on our older file servers using hard drives over iSCSI, it caused visible performance problems if a pool ever had 2 chunks from the same physical disk. Fortunately, these seem to have gone with our new SSD-based file servers. Even with all of this, we can't necessarily let people expand existing pools by a lot of space, because the file server their pool is on may not have enough free space left, especially if we want other pools on that file server to still be able to expand. When people buy enough space at once, we generally wind up starting another ZFS pool on a different file server, which somewhat cuts against the space flexibility that ZFS offers. People may not have to decide up front how much space they want their file system to have, but they may have to figure out which pool a new file system should go onto and then balance usage across all the different pools. Which again, the whole point of ZFS was if we put all the free space in one place, then we can just use it as we need it. Mm-hmm. But, you don't always actually have that flexibility. Another thing we do is we sell pool space to people in 1 gigabyte increments, although usually they buy more at once. This is implemented using pool quotas. And of course, that means that we don't even necessarily have to grow the pool space when people buy space. We can just increase their quota as long as we have the space to back it up or to provide it. Although we can grow pools relatively readily when we need to, we still have the issue that adding a new VDEV to a ZFS pool doesn't rebalance space uses across all of the pool's VDEVs. It just mostly writes new data to the new VDEV. In an SSD world where seeks are essentially free and we're unlikely to saturate the SSD's data transfer rate on any regular basis, this imbalance probably doesn't matter as much. It does make me wonder if nearly full VDEVs actually interact badly with ZFS's issues with the coming near to full quotas, and a follow-up to that.
Yeah, this is definitely an interesting way of growing.
Yeah, there must be more process reasons behind the reason they're doing it that way. But it sounds like they have multiple pools on a file server and using chunks of the hard drive, and they're conserving some of the space on the hard drive to be able to expand any one of those pools at some point.
Yeah.
Which I suppose makes sense, although it's like, what if you just made it all one big pool? But sometimes it comes down to you need to be able to guarantee a certain level of performance, or that a heavy load on pool A isn't going to impact pool B very much.
Yeah, different use cases for different pools. Then we jump a little bit into Linux land today, because many of the BSDs are asking, why was ifconfig on Linux deprecated? And this is a comparison on the blog.forhan.codes. It's a Linux maintains bugs. The real reason ifconfig on Linux is deprecated. So in my first installment of FreeBSD versus Linux, I will discuss underlying reasons for why Linux moved away from ifconfig to IP. In the past, when people said, Linux is a kernel, not an operating system, I knew that was true, but I always thought it was a rather pedantic criticism. Of course, no one runs just the Linux kernel, you run a distribution of Linux. But after reviewing userland code, I understand that significant drawbacks to developing just a kernel in isolation from the rest of the system. Let's say a userland program wants to request an object from the kernel. Kernel structure might be something like this. So you have a struct foo with a size t size, a character array called name with the size of 20, and then you have an integer value. Okay, so on POSIX systems, a typical way to communicate with the kernel is to open a file descriptor to the appropriate system and send an ioctl with a pointer to where the kernel should store the responding data. FreeBSD might perform this task as follows. So you have struct foo x, you instantiate the structure, and then you do ioctl with the file descriptor, and then you do command underscore request underscore foo, and then a pointer to x to the struct you just instantiated. Linux should do the same, and to be fair, it typically does. This manifests as software source that requires Linux kernel headers. But because userland tools are maintained independently of the kernel and sometimes are even explicitly written to be cross-platform, they typically maintain their own copy of data structures and macros independent of the Linux source tree. So far, so good. This might even produce the exact same binary output. But what happens if the kernel structure or behavior changes? This could be due to a bug fix, an added feature, or an optimization. Either way, the structure may change. On FreeBSD, this is not a problem. They update the kernel and userland tools in tandem. In fact, because both the kernel and userland application are in the same source tree, they can even share the same header files. For third-party userland applications, FreeBSD provides highly stable libraries that do all the kernel interactions, such as lib802.11. It's worth noting that OpenBSD and NetBSD do not have these libraries because the kernel interface itself is highly stable anyway. FreeBSD even provides a compat layer in the rare cases that an older binary fails to run on modern versions of FreeBSD. Conversely, on Linux, because the kernel and the rest of the operating system are not developed in tandem, this means updating or fixing a kernel struct would almost guarantee to break a downstream application. The only way to prevent this would be to conduct regular, massively coordinated updates to system utilities when the kernel changes, and properly version applications for specific kernel releases. Quite a Herculean endeavor. This also explains why systemtab, one of Linux's main answers to dtrace, does not work on Ubuntu.
Yeah, trying to coordinate this would be almost impossible in Linux because, CentOS is like, well, we're using this 3.10 kernel, and Ubuntu is like, we're using this other kernel, and they're massively different, but we're all trying to use the same GNU software, but we're all using different versions of it too. And
yeah,
if you've ever dealt with like the dependency hell of Ruby, that's what you would get if they didn't do this slightly weird thing they do on Linux.
Oh, and here goes the next thing. Also, Linux can never have an equivalent of lib802.11 because there's no single standard library set. Even for the standard C library set, Linux has glibc, usclibc, diatlibc, bionic, and musl. Rather than guessing the underlying C library implementation or falling into dependency hell, applications default to the most low-level implementation or their requested functionality. Some tools, such as ifconfig, resort to just reading from the /proc file system. And Linux's solution to this problem was to create a policy of never breaking userland applications. This means userland interfaces to the Linux kernel never change under any circumstances, and even if they malfunction and have known bugs. That is worth reiterating, Linux maintains known bugs and actively refuses to fix them. In fact, if you attempt to fix them, Linus will curse at you as manifested in this email. There's a link here from the Linux kernel.
Yeah, so in Linux, you'll often end up seeing system calls and octals with like 2 or 3 on the end of it, or 4 or more, just because they would make a new interface and leave the old one so the old applications would work, and they'd make the new one that doesn't have the problem. But, you only want to do that every so often. Otherwise, you would just end up with, you want to call that number 17, which gets a bit ridiculous.
What's the highest number at the moment? Yeah. And this leads back to the topic. Have you ever wondered why nearly every distribution deprecated ifconfig, a standard networking tool dating back to classic Unix? When Linux first implemented multiple IPv4 addresses on the same physical interface, it did so by cloning the interface in software and assigning each clone a unique IPv4 address. For example, ETH0 could be cloned with ETH0:1, ETH0:2, etc. From a programmatics perspective, ETH0 still only had one IPv4 address. As time passed and developers updated the kernel, it allowed users to assign multiple IPv4 addresses directly to the same interface, bypassing the need for cloning. But Linux's API has not changed. It still only returns a single legacy IPv4 address per interface. An interface should have multiple IPv4 addresses, but ifconfig will still only report a single address. In other words, and it currently stands, ifconfig lies to you. I do not fully understand they did not just update ifconfig. Random IRC rumors say there was a failed attempt due to ifconfig's convoluted codebase, but for whatever reason, this leads to the completely new tool IP. By contrast, FreeBSD just updated their ifconfig in tandem with any kernel updates, and there was no problems. Simple. This also explains why Linux has multiple tools for seemingly highly correlated network tasks. Rather than working together to create a consolidated tool, Linux has IW, IWconfig, and brctl, etc. Whereas FreeBSD just has different drivers for its ifconfig implementation. For the record, I think IP syntax is cleaner than ifconfig syntax, as the latter is a victim of IPv4 legacy syntax. If both tools work just fine, it might be worth having ifconfig for legacy scripts during a transition period, but making IP the future. That would be perfectly fine, but it would be the ideal if both tools just worked, rather than needing to abandon the tool because it is broken.
Yeah, like it seems the solution would have been make a new syscall or a new file /proc that has the new many addresses per interface set up, and make a new version of ifconfig that uses that, leaves the old interface there, so old versions of ifconfig can still work with the newer kernel, but newer versions of ifconfig will also work. But apparently not.
Yeah, software maintenance is one big trouble nowadays. It might be easy to write the software, but maintaining it over the years, that's a different story.
Yeah.
The next one is a bit more for the eye candy folks. Clear your terminal in style.
If you're someone who likes to habitually clear their terminal, sometimes you want a little excitement in your life. Here's a way to do just that. So the first one is to get a % chance to run a command. This post revolves around the idea of giving a command some % chance of running. While the topic at hand is not serious, this simple technique has potential in your scripts. Note that this only works in bash. They just take the number or the variable random, which is automatically assigned to a random number in some small range, modulus it by 10. So basically, what's the remainder when you divide this by 10? And if it is 0, then it does this, and otherwise it does that. This gives you a 1 in 10 chance of running do this, and a 9 in 10 chance of running do that. You could omit the or do that and just have a 10% chance of do this and nothing else. So then it says, Jonathan Hartley, creator of the popular Colorama Python module, also made a cool little terminal application called cbeams. We can use this, uses animation with a little bit of bash goodness to clear our terminal. So first he uses Python pips to install the cbeams tool. And he says, this is an animation command which overwrites the current text on the terminal. So if you run cbeams-o, to attach it to clear, we extend the command's functionality. So he makes an alias for the clear command that has a 1 in 10 chance to run cbeam-o for 6 seconds. So that, 1 in 10 times when you run clear, an animation of explosions will play for 6 seconds and then it'll clear your screen. The other 9 in 10 times, it'll just clear your screen like you asked. Or there's the SL command, which I think was created just to tease people who accidentally typo ls as SL. But when you run it, an animation of a steam locomotive runs across your screen. So again, in this case, he aliased clear 1 in 10 times. It will run a steam locomotive across your screen before clearing it. Or there's another one called cmatrix, which will, again, make it rain like in the Matrix. And he runs that with timeout 3 so that it'll play for 3 seconds and then clear the screen.
That might be more eye candy.
Lastly, he's got an extra bit. If you're into the VT100, which was the video terminal made back in 1978, he says there's an archive of animations made with this tool, some dating back as much as 40 years. They are a lot of fun to look back on, and I can't imagine how much time it must have taken to make some of these. So take a look at the large archive over here, and also provides a Perl script which allows you to view the files at the speed they were meant to be played at. And he's got an example of a Twilight Zone one.
I like the surprise factor that you only do it every other time
Yes, or 1 in 10 chance, yeah.
Because otherwise it's like boring after the 10 times you've did this.
And having to wait 6 seconds every time you run clear is annoying, but having it happen only every so often.
Or you could say cycle between these 3 methods of clearing the screen, so you have extra surprise how your screen gets cleared. I always see people like typing really clear into their terminal instead of using the much quicker Control L shortcut. Is that like a habit?
I only clear my screen when I'm about to log out on the like actual physical console. In general, I want what was on my screen to still be there. It's like I was reading. It's like the most annoying default feature on Linux is when you exit a man page, it clears the screen.
Yes, that's bad.
Or it doesn't actually clear the screen, but it erases the man page. And it's like, I was reading that. It's like, I read the man page, I scrolled to the section I wanted, and it has the example, which I'm about to do something with on the command line, and you've made it disappear from my screen, and I'm very upset now.
Yeah. That was the error message I was looking up. So, yeah. Definitely check out those screen saving styles and maybe surprise your colleagues sitting next to you with a little bit of eye candy next time. Time for feedback and questions this week. Many of the things that you send to us at feedback@bsdnow.tv will end up in a future episode, whether it's a question, some show feedback, or something else you might want to know from us. This is the way to get in touch with us. So 3 people did that. The first is Guy with AMD GPU help. I guess he's requesting help, not having help for us.
No, it looks like he's actually helping.
Oh, okay. Even better. So we don't have to do all the work. So subject is the AMD GPU driver install. So first of all, it's like a how-to.
It's a mini tutorial.
Better safe than sorry. Create backups for config files. Always good to do.
Yeah, so it's backing up rc.conf and loader.conf and creating a ZFS boot environment so you can always go back. And it says the driver requires users to be in the video group so that they can actually access /dev/video. So they actually want to do pw group mod video -m whatever your user is, and now they'll be in the the video group and be able to access the video card. As it says here, yes. Also having them in the wheel group is very useful because then they can use SU to get root access and so on. And the other one you might want on like a laptop is the operator group, which lets you do things like reboot and power off without having to be root. Once those are in place, you can install the AMD GPU driver. So package install drm-kmod and add AMD GPU to the KLD list in your rc.conf. The line running cap mkdb on rc.conf doesn't make sense. rc.conf isn't a database. A bunch of the other files are, like login.conf and the password file, but rc.conf is not. Anyway, then he's saying set the initial console resolution. The keywords and tricky phases are located in the VT man page. Setting the default to 1024 by 768 will work on the majority of cards. So you can see he's in his loader.conf. He has kern.vt.fb, which is frame buffer, and the default mode set to 1024 by 768. And then it also talks about optionally disabling syscons, although I think if you have VT, you won't need that. And then reboot, and it says the system console buffer is off, so only random noise or sparkles will be on screen until the video driver is actually loaded. If screen is good, then you can continue in not going back and trying again. You can, change to a higher resolution or whatever. If you're looking at your D message, you can get a list of the available resolutions and so on. Mm-hmm. And you see, like he, for example, found that he could set his to kern.vt.fb.modes for HDMI-A-1 to 1920 by 1080.
Ah.
And then when X takes over, the full resolution of the monitor and the video card will be available.
Oh, cool. This is pretty straightforward. Mm-hmm. Thanks, Guy, for sending that in. ML Schroyer 13 is next with VLANs and jails. Goes like this. Hi guys, great show. Thank you. Like many others, I feel I should be putting in my due diligence prior to asking questions. Luckily, you seek feedback and questions so much that you've convinced me to just ask, which is great because I don't know when I'll have time to research and test this concept on my own. I find jails to be quite elegant. At a high level, they're easy enough to understand, but getting into the weeds will sometimes produce questions that aren't easy to answer. I hope you can help provide some clarity for how to approach what I'm interested in doing. I've got multiple VLANs on my network with a pfSense router. My home secure trusted network is VLAN 10. It houses a PC or two, as well as a UniFi managed switch and a cloud key. My FreeBSD server is by itself on VLAN 50. On the server, I've got jails for Bitwarden, Bookstack, and others. For the internet access, I have a cloned loopback device, meaning they're on a separate internal network. There's a PF rule to nut their outgoing requests. What I want to do is create a jail to act as a backup or substitute for the UniFi cloud key. The cloud key provides the management interface that links the UniFi switches together and assigns the VLAN traffic rules. The problem is that the switches and cloud key or proposed jail must all be on the same VLAN. What I think I should like to do is send a VLAN trunk to the server. The server host would have to tag all its outgoing packets with VLAN 50, and the unified jail would have to tag its packets as VLAN 10. Yes, I could also probably leave one of those as untagged and the other as tagged, but I prefer to tag it all. This should work, right?
So yes, if you set up the switch to send all those VLANs tagged to the machine, on your FreeBSD machine, I'm guessing right now you have it just untagged, so you have IGB0 or whatever with IPs on it, but you can create these VLAN interfaces. Like if you just do ifconfig create IGB0.50, it will create a separate interface that is always tagged as VLAN 50, or ifconfig IGB0.10 create will create a filtered version of IGB0 that only has VLAN 10. So then you can use that in the jail. So let's go to the questions now.
Yep. The first is, does my approach make sense?
Yes, that is exactly what you need to do.
The second, would the unified jail need to be a VNet jail?
That depends. It might be easier. If it's a VNet jail, then you can just bridge it directly to that VLAN 10 interface, and that'll work. And it also has the advantage of the UniFi stuff running in the jail will have access to a complete network stack. It might not be required. If you just have the IP address of what's going to be your UniFi jail set on the host and it's shared into that jail, as long as it's on the right interface, it'll get tagged correctly. But I don't know what UniFi is going to try to do and whether a VNet jail will make it better or not.
And the third, how do I add VLAN support? Is PF involved?
PF is generally not involved, although it might be a little bit. So if you look at the FreeBSD handbook section on VLANs, basically you just add them to your rc.conf, and you would put all the IPs that are currently on your network, that is VLAN 50, onto the VLAN 50 interface, and some new addresses for the VLAN 10 interface, or no addresses, maybe if you're just going to bridge it to the VNet ePair for your unified jail. And then you'll have, basically, it will look like you have separate interfaces for each VLAN, and when the packets go out, they will be tagged with the right VLAN and then go out the actual Ethernet interface. So you don't need to have PF involved at all, but you might need to update your PF config for the fact that all of the IPs that used to be on your raw interface are now on the VLAN 50 version of that interface. So the name of the actual interface might have changed, and you might need to update your pf.conf a little bit and make sure that it's not blocking the stuff trying to go out on VLAN 10 or anything like that. But you don't actually have to involve PF beyond that.
Oh, good. Less components involved.
Yeah, because I have something kind of similar. I have my home VLAN, which is my house number because it's low enough, and then an office VLAN for work stuff that's VLAN 100. My personal file server happens to bridge across both of those, but the Plex that I run to be able to watch videos on my TV upstairs should only be able to work on the home VLAN. It shouldn't see anything from the office VLAN, and so on.
Cool. So thanks, Matt. If you have solved this, then you could send up a follow-up with like a how-to or blog somewhere. Then that would be also interesting for other people to replicate at their setup. Okay, then it's the last one. The question is about ZFS suspend and resume. Quick and easy. Do you consider the use of ZFS on a laptop to be safe when using suspend to RAM? Definitely is. Because during my tests some time ago, I remember seeing some messages concerning NVMe 0 on resume, though I can't quite recall what they were all about.
There was a bug in FreeBSD at one point where the order things were put to sleep in or whatever meant that the NVMe had a command outstanding when it went to sleep. When it woke up, it would time out and then reset and try again and finish. So that the error wasn't serious or anything. ZFS is safe because even if that data somehow got lost, ZFS would still have a consistent file system. It would just be from 2 seconds before you resumed before you slept instead of when you slept. But most of the time, it's going to be able to, that's still going to be in RAM and will get written out properly when it comes back up. And yes, it even protects you in the case of if you have data that's actually still dirty somehow when you suspend, obviously it'll still be there when you resume. But if, for example, you do what I've done a couple of times, which is suspend your laptop and then not resume it until sometime after the battery has died, and that data would be gone, that might cause a problem with other file systems, but with ZFS, it will always be okay.
So yeah, no worries running that on your laptop. So yeah, thanks for questions this week, and hopefully we'll see more in future episodes. Again, send this to feedback@bsdnow.tv or any other comments, feedback that you have for the show that will be included in a future one. Thanks for listening, and keep safe, keep healthy, and see you next time.